Good afternoon, dear listeners. My name is Natalia Moiseienko. I would like to present you our paper which titled Fluid Flow Modeling in Houdini. Computer graphics today is one of the main directions of information technologies that develops most stormily. By means of computer graphics, it is possible to do visible or visualize such phenomena and processes that cannot be seen in reality. It is possible to create the evident character of that in actual fact unobvious. Scientific visualizations is graphic representation of data as to the means for a study and understanding of data. Sometimes such method is named the visual analysis of data. Distinguish scientific visualization and graphic presentation. Graphic presentation is created first of all for an information and result transfer by methods that it easily to understand. In scientific visualization prevails aspiration to understand data. However, often both methods combine. From the point of view of calculation, sci-viz is part of the greater field they named visualization. It plugs research in computer graphics, processing of images, high efficiency calculations, and other areas. The same instrument that is used for sci-viz can be used, for example, for animation or multimedia presentation. Programmatic facilities that allow to create three-dimensional graphic arts, design the objects of virtual reality, and create on the basis of these models images very various. There are many software for creating graphic objects for presentations and demonstrations. The most popular tools 3D Max, Maya, Blender, and Houdini were analyzed. Houdini from CytFX. It is professional programmatic package for work with three-dimensional graphic arts worked out by company CytFX. A main difference of this package is in that he is a visual programming environment, widely used in industry of visual effects for creation 3D images. Procedural approach on the basis of nodes of Houdini provides to the digital artist a high power level, flexibility and control. This key working process likes to not all, but Houdini also has more traditional instruments for the direct cooperation with ground on the screen. As well as in Maya, this power level and not standard working process can be difficult for beginners. CytFX offers Houdini Apprentice, free version of Houdini FX that students, artists and amateurs can use for their personal non-commercial projects. A free version gives access to practically all functions of valuable Houdini FX for development of the skills and prosecution of the personal projects. Full function Houdini Indie also offers an accessible commercial variant for small studios. Also, Houdini is mainly used for dynamic environments and effects of particles. He includes a complete set of tools for artists that want to use him for other areas such as design, animation, or rendering. Houdini software is a suite of procedural modeling animation, effects, physical simulations, rendering, and composition. To work with this software, you need to understand the basic principles of procedural modeling. That is, a number of methods in computer graphics to create three-dimensional models and textures. Procedural modeling is often used when it is necessary to create three-dimensional models of complex shapes, or when more specialized tools, such as modeling of plans, architects, and etc., are required. With the feature provided by Houdini, you can build models, objects, simulations, and customize them, and test their performance by running and testing simulations directly in the editor. We created the simulation of fluid flow in Houdini. For the beginning of work with the design of stream of liquid, it is necessary to create an object that will be source of stream. In this case, this was a primitive as a sphere. For that it was added not transform that will allow to change such parameters of sphere as size, position, and turn. In order to visualize this as a liquid with different viscosity will flow down four surfaces, it is necessary to add another object that will imitate this surface. We'll change a size and position of sphere by means of not transforms so that she was above a sloping surface. We'll use nodes, flip source, and DOP network in order to add two properties where the sources of node particles that will imitate the fluid flow. Node DOP network contains another network of nodes, sleeve solvers, that is responsible exactly for creation of particles. Connecting the network of flip solver to the sphere, it is possible to see that around here the cloud of particles was formed. Now particles are only created around a sphere. In order to imitate behavior of stream of liquid, it is necessary to connect to the network of flip solver node gravity. It will cause particles to fall vertically down. Starting a simulation, it is possible to see that behavior of particle anymore looked like behavior of fluid flow. But now particles only fall downward within the limits of the set area and in any way does not cooperate with a surface that was added before. To realize it, it is needed to add a reference to the static object to the network of flip solver, namely nodes, static object, and static solver. Executing previous manipulation and starting a simulation, it is possible to see that particles physically correctly to fall vertically down and flow down from a sloping surface to the container. At this stage, the particle stream behaves as a liquid that does not have properties such as viscosity, temperature, or density. You can add these properties in the Flip Solver network settings window. The viscosity of the liquid is the viscosity parameter. In this model, we set it to 100. By running the simulation again, you can see how the viscosity parameter affects the fluid flow behavior. The stream flows from the surface much slower and looks like a viscous substance such as honey. The result of the behavior of liquids with different viscidity can be seen in Figure. Next, let me show you our videos. The first one demonstrates fluid mixing simulation. And second illustrates simulation of fluid flow with different viscosity parameters. Conclusions. Application for creating three-dimensional models and structures expands the functionality of education in the field of physics and information technology. This makes the learning processes more visual and fun. Using the proposed software and the models implemented in it is more productive than using traditional experiments and video materials. The appropriate form of training using interactive presentations in a virtual environment is useful for deeper understanding of the simulated processes by visualizing and complex objects. Thank you for your attention.